Now let's move towards the real stuff, because math is all about practice. Until you solve questions, you will not really understand the concept. So let's move on to our iPad and solve a few examples together. Let's look at our next example. The difference between this and the previous question is, here the denominator has not been factorized for us. But that is still the first step. We need to identify the factors of this denominator. I see a quadratic here. We all know a quadratic may or may not have rational factors, so that is what I'll check for first. For that, you can actually use middle term breaking, or you can use the quadratic formula to find the roots, which you can then convert into factors. I'll go for the middle term breaking approach. So let's try and find the factorization of this denominator. X squared plus 3x minus x minus 3. Taking x common from the first two terms and minus 1 common from the last two terms, I can see the factors are x plus 3 and x minus 1, which basically tells me that this fraction can also be written as 3x plus 5 upon x plus 3 into x minus 1. With this form, I can easily tell that this fraction will have two partial fractions, mainly because there are two linear factors in the denominator. And those two partial fractions are going to be proper fractions. So for linear denominators, you can have only constants in the numerator. So a upon x plus 3 is the first one, and b upon x minus 1 is the second partial fraction. After getting this form, you just need to take the LCM, use some algebra to find the values of a and b. Let's do that. So taking the LCM on the right hand side, I'll multiply a with x minus 1 and b gets multiplied with x plus 3. On the right hand side, we have this, and on the left hand side, we just have 3x plus 5. I'm not writing the denominators again because, like we saw in the last example, they're going to be exactly the same. So there's no point comparing the denominators. We just need to compare the numerators and find the unknowns, for which, once again, we have two methods. Either expand the right hand side and compare coefficients, or use the cover-up method. I'll go for the cover-up method. For the cover-up method, let's say I want to find a first. So I have to figure out the value of x which makes this 0. And that's obviously minus 3. To make this 0, I can only take x as minus 3. So this tells me when I take x as minus 3, I'll get one equation only in terms of a, using which we can work out the value of a. Let's begin. So x is minus 3 throughout. This entire thing goes to 0, and from here, when you find the value of a, I believe it is going to be 1. This is minus 9 plus 5, so minus 4, and that's equal to minus 4a. So yes, a is 1. So I just found the value of a using x as minus 3. In the next step, I'll find the value of b using x as 1. Because when I take x to be 1, this goes to 0. Let's continue on the next slide. Taking x to be 1, the equation I get is 3 times 1 plus 5 equals 0 plus b times 1 plus 3. That becomes 8 equals 4b, and therefore b is 2. I have a and b, which means I have the numerators and hence the two partial fractions. Let's go back and write down the partial fractions using a as 1 and b as 2. So this basically is 1 upon x plus 3 plus 2 upon x minus 1. This is the answer. These are the partial fractions for this original fraction. So that is the thing. You always have to start with the factorization of the denominator if it's not already factorized for you. Hope you understood everything in this lesson and all the lessons we have covered before this. But in case you still have any queries, you can always approach us in the discussion box below.